Oh my god, thank god. Hello? Jeez. Wait, is that past tense? Okay, good, we're still going. Okay. So you can hear me if I'm doing this. Interesting, okay. I'll just wait for people to trickle back in. So you can hear me if I'm doing this. Interesting, okay. If any of you guys are looking at internet providers, never go with TELUS. It is like the worst thing in the world. It's probably comparable to sticking your toe into a wedge and just hitting it with a hammer. Like, it's probably more painful than that. I hate it. God, I wish I had Shaw. I'm guessing you know what I'm talking about, Waffles. God. You have fiber? Lucky. You're living in the future. The presentation won't be that much longer. After this, I'll just be setting you guys up with, after I go over some of the technicals, I'll just be setting you guys up with basic stuff. Ugh, those add everyone notifications must be getting annoying. You sent 4 in the last, 10 seconds. Yeah, give or take 6 more slides. Oh, what a disaster. Alright. We'll just switch to main for now. Our viewership dropped in half. You want me to tell you more about myself? Okay. My name's Julian. I am the president of the competitive programming club. I've been about an active member for the last couple of years now. Born in Calgary, lived in Calgary all my life. Nothing much to it. Computer science, you know the works. What else? I wasted half my life on Valorant this summer. That was fun. Yeah, no, I majored poli-sci. I thought that would give me the best skill set for the tech world. Just makes sense. Yo, I got up to Plat 2 only using the Bucky. Not gonna lie, I was pretty proud of myself for that. Alright, people are trickling in slowly. I'll give it another couple of minutes. Sorry about the wait. Oh, how's someone able to talk? Okay. I'm getting talked to by my own account, so I guess I'll start. I'm getting prodded by someone to start. Alright, so, back to it. Big O notation. So, quick recap. We were talking about how time complexity is one of the main things you have to consider when dealing with competitive programming. And then we extended that to say big O notation is how we express time complexity when we're dealing with algorithms. So once again, it is the time a set of code takes to run as the number of inputs go to infinity. So it's the growth rate. Pretty much, as you add more and more problems, your code is naturally going to run slower. And if your code is inefficient, then it'll accumulate more and more slowed time, or more and more wasted time, as it has to process more. So it's like the more times you have to run the code, if it's inefficient, it'll create more and more wasted time. But if it's more efficient, then it will create less wasted time with every time the code has to run, if that makes sense. It's, it's just a way of analyzing the algorithm's performance. So, with I guess I'll start with the most basic, which is primitive operations, and we call these constant time or a big O of 1, because it means that there's no variable there. It's literally just runtime of an arbitrary time unit of 1. And since there's no variable there, it means that there's no scaling. So when you're doing something like, let's say you hard code 1 plus 1 and equals 2, you are looking at a run big O of 1 because it's literally just one line of code. Like, there's no potential for growth. It's just hard coded. It'll run once, and then that's its time complexity. When you start dealing with blocks of code, it gets a lot more complicated because we have to consider the number of inputs, or we call it n, because for every n, our runtime increases. Going back to what I said earlier, there are data sizes where it is okay to use algorithms marked as terrible, as you can see over here, like these really dark red ones, rather than amazing, because terrible algorithms can process such little data that it doesn't accumulate as much wasted time, and it would still fall under that 1 second CPU limit. So if it's faster for you to code something that's terrible, and you know it will fall under the CPU limit, then why would you bother coding something that will take, let's say, an hour, and it's in the amazing, but it's in the amazing field right here. Like, it doesn't matter because at the beginning the scale factors aren't as intense. So this is probably the most important thing you need to know about competitive programming. And it may not be intuitive, but the good thing about Big O is that for most major algorithms, it has been calculated for you already, which is very nice. One thing you'll notice is that there is a strong correlation between the quality of a Big O value and the time it takes to implement something. Naturally, if you focus on one thing, you'll get faster at it. It might be faster than something you've never tried before, but if you're learning something for the first time, the Big O value being amazing and stuff, those ones are definitely harder to code than the ones that are terrible, generally speaking. There's obviously exceptions to that rule. Example, we got something called selection sort here, which is pretty primitive. So you got this block of code here, and it looks hefty. It's looking at it, you're gonna have to take a few seconds, maybe a few minutes to analyze what it actually does. But in order to calculate its time complexity, it's actually a lot easier than it looks. Your eyes would obviously fixate on this beginning part and all this stuff within the for loops and all that other stuff. But all we really have to do is look at the conditions of the for loop. Because you see, we're assuming worst case scenario. And we know that the input of the array, or the input, is an integer array of x size. We'll call that n size, right? Integer array of n size. So we know that its upper limit for its first for loop is its array size. So it will go through every single element of the array before it terminates this for loop. But in addition to that, for every one of these for loops, we're calling another for loop, which can go up to j is less than or equal to I. And j And I, which is up here, can equal to up to array dot length minus 2. So essentially, we're going through the entire array twice. For every iteration of this for loop, we're going through this for loop. So you can see it as like a square function, basically, because you have 2 for loops here, and one invokes the other for the same amount of n times. And it's pretty much, obviously when you get into more complex things like recursion and all those other graph type algorithms, it's going to be obviously a lot more difficult. But like I said earlier, the algorithms that we know about already have their big O calculated, so it actually saves you a lot of time. Let's see if I missed anything here. Yeah, two for loops, one nested within one. Then you're looking at probably a big O of n to the power of 2, which going back is pretty ass if I remember correctly. Yeah, no, it's considered terrible. So there's a lot better ones out there, but big O is a lot simpler than it sounds. More time complexities. So like I said earlier, pretty much every single algorithm that you're going to be using at the beginning or even in the future already has their time complexities calculated for different operations. So if you need to access an array, you'll notice at the very top it's green, probably for excellent or good. So you know to use that for those functions, and then blah, 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 blah. You can look up pretty much the time complexity of anything you want, and you can get them immediately. Eventually you'll do enough problems where you will be able to think, wow, I got this really weird looking problem that needs X and Y and X, Z, Y, I don't know, I'm just making up garbage. But you will quickly jump to an algorithm that you will know how to quickly implement and that you know will work. That's kind of mindset you'll develop with experience. And it'll get easier over time. But once you realize what algorithm you want to use, the only thing you have left to do really isn't to implement them, which is arguably the harder part. That being, with time complexity out of the way, that is a very, very basic rundown of time complexity. We'll get more into it as we go into our more advanced topics. We're going to be going into greedy algorithms, divide and conquers, and a whole bunch of other ones with the other lectures pretty much starting next week. So we'll be going into more technicals next week. But for the time being, if you're not already in the Discord, which honestly doesn't make much sense given that I just advertised it on the Discord, you'll notice that there is an announcement in Club Announcements that looks exactly like this, that links you to a Google form, and also to make an account on Caddis. Now, we use Caddis to administer contests every week, which are basically problem sets for our club members to do to practice competitive programming. We need you to register for that. And the reason why I put this slide here is so that you could probably do it while I talk. It's very important that you register. We need that for our leaderboard, and we need that for you to actually participate, which is kind of important. So register, fill out that form, and then I'll move on to the next slide. So every single week, our lectures will look like this. We'll have a lecture from one of our executives, which the schedule is to the right, but it's also on our website, which you can find in our club information, I think social media or something. This is everything we're covering this semester. So next week we're going into data structures, and then number theory. You guys know how to read. I don't have to read that through for you. After that, we start a Caddis contest. So you'll notice that in club announcements on the Discord, I don't know if it's streaming my screen or if it's streaming my... Oh, it is streaming my screen. So in club announcements, you'll notice that what was I getting at again? In club announcements, you'll notice that Thomas announced we have, or did he put it in general? Okay, give me 1 second. Does anyone know where that contest link went? It's in contests. Right, we have a link that's contest. Okay. So, and you'll notice in the contest tab that we have a contest here. So going into this, it will look like this. It looks like Chris Sun has done every single question already. Even okay. That's really cool. And you'll be able to join. What happens is you'll be able to sign in using your account once you make it. And when you go in here, you just click join contest at the top here, and you will be a part of the contest. You are successfully registered, and then you click on the problems, you click on a problem, and you click submit. Yep. And then it allows you to do your submissions. That's a lot to process. If you need me to explain that again, just feel free to DM me. I know this stuff is getting glanced over, but it is important. So, after the Caddis contest at about 7:30, I will be going over solutions to some of the problems in the contest. So if you find we will give you a chance to complete the problems on your own accord, and honestly you should, because most of the stuff is just learning how to do it yourself. But we will be going over solutions to these problems to kind of help you learn. So after this is over, tune in and we will maybe help you out where you got stuck. Next one, contest format. So we normally have about 9-10 problems. 3 of them, maybe I think this week it's different because we are expecting some new people to join, but we have 3 about 1.5 difficulty, maybe around 1.5, 4 at about 4.0, and then 1 to 2 that will be related to the lecture topic. So obviously this time I'm not really going over anything specific. So I'll just be going over the first 4 problems in our problem set. So those are the problems I'll be going over. But typically we'll have 1 to 2 problems that will have solutions told at about 7:30. The whole contest runs for about 2 hours to 8. So at about 7:30, we'll start going over answers to the problems. The contests will run for 1 week. Yes, not for 2 hours. Yeah, okay, no, we changed that. So you have a whole week to do these problems, but we're only going to give you the solution to the first 4 at about 7:30 every week. So stay tuned for that. I'll probably just leave the live stream open and then pop back in at 7:30. I'll be doing some of these questions as well. After that, we have the leaderboard. So we have a system on our website where we keep track of your progress as a competitive programmer. With every single problem you add with every single problem you solve on Caddis, we have it automatically scraped and put on a total pool of points on our website. What this means, it's not really a public shame kind of thing. I don't even think that people look at it. It's more for us to distribute awards. But if you're really competitive, you could definitely look at this and feel a sense of accomplishment from being at the top above everyone else. But what you should really be concerned about is that the top 3 do get some pretty sick prizes. In the past we've had some Google's merch. I think this year we have quite a bit of money for draw prizes, so we might go all out on that. But we could also give you a business opportunity because you get to have a lunch with the CTO of R-Curve, which is pretty big. We've had a number of contestants get to the top 3, have that lunch, and then they've had some pretty good opportunities coming out of that. In addition to that, there are also random prizes that are drawn at the end of the semester. So you could win a $20 gift card. We just have a random name roller. And we'll end up probably mailing it to you or giving you a code or something. But yeah, you can. There is a point to this. Not only will you be learning stuff, but you can also come out with some pretty nice stuff, I'd say. But yeah, the leaderboard, I think that's about it. So, I forgot about this. This is important. So coding for the problems. Yeah, I should have probably remember this. So when you first start and you know how to code, the hardest part is going to be how to take inputs. Thomas, an executive that's been with us for God knows how long, he's been invaluable. He's created a guide in learning resources that is just like, it's amazing. It'll walk you through how to take inputs for 4 of the questions on the contest, and it also teaches you how to just the basics. Because like when we have to onboard new people into the club, typically they get the most frustrated with learning how to take inputs. So please do yourself a favor, go into learning resources, scroll all the way to the top, and read this document. It'll help you out big time. This isn't a zero knowledge club, as much as I'd like it to be the contrary. You will need to know, you will have to have a baseline knowledge of coding, of languages in general. So you don't expect to learn how to, like the very bare bone basics of learning how to code. I'd recommend some online courses if you're really keen on that. But our free code camp's great. But we can't exactly teach you the basics. But that being said, no question is stupid. If you have any questions and you want to ask us anonymously because you feel like it's a stupid question and you don't want people to know that you asked it, just DM one of us. We are more than happy to help you. But more specifically, DM me, since this is my lecture, and I feel bad putting that responsibility on other members. So, that concludes my presentation. You guys will have all week to complete this contest. I would encourage you to do so and, I don't know, find some fun in it. Next week we'll be going over some pretty cool stuff and more or less follow the same format. You'll learn a lot. You'll meet a lot of cool people. It's a great place to be. We will be back at around 7:30 to go over the solution for the first 4 problems. Contest link is already on the Discord, so I'm going to leave the stream open. You guys can do whatever you want until then, but preferably you should do the contest set. Again, if you have any questions, DM me. If you want anything clarified, just DM me. And I'll catch you later. Okay, so this is the confusing part. I'm pretty sure if I click on be back or something, they can still hear me, and I don't know why. Do I just click mute? Do I just click mute? Do I just click mute? Okay. Okay. Wait, my audio is still here. That's stupid. Okay. Wait, my audio is still here. That's stupid. Okay. Wait, my audio is still here. That's stupid. 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 What? Is it echoing the same thing? How does this work? What? Is it echoing the same thing? How does this work? Okay. What? Is it echoing the same thing? How is? Okay. Give me a second. I'm experiencing triples. Echoing the same thing. How is? Okay. character? Hey, if you haven't filled out the form, do that, please. I guess there's no way for me to confirm that you heard that, so yeah, see you. Alright. I promised I'd give you guys solutions. Well, this might be a bit of a cop-out. Alright. I promised I'd give you guys solutions. Well, this might be a bit of a cop-out. Alright. I promised I'd give you guys solutions. Why does it keep repeating itself? Well, this might be a bit of a cop-out. Wait. Oh, because I'm listening to the stream at the same... Ah! Okay, I get it now. Okay, I'm stupid. If I get rid of the desktop audio, that should fix it. Alright, we Gucci. Alright, we are ready to go over the answers. So, as a little bit of a cop-out, but we're basically just going over the solutions to the introduction here. For the first four, like, since this is an intro, this is kind of an introduction to what we do here. Thomas has created in-depth solutions on that learning document to solving all of these problems. I could break it down, but at that point I'm just reading off slides, and it might be kind of stupid for me to do that. I'll post the link inside the stream chat. Of course. Give me 1 second. I'll post the link inside the stream chat for you. And if you guys want, if you guys have any questions whatsoever, you can ask us on general coding help, anything like that, and we'll help you out. I'll just post that in 2 seconds here. Is that editing? So, when we scroll down to this document, you'll notice that he gives you a breakdown of how to take inputs for pretty much every single problem. Once again, I want to emphasize that the input is the hardest part. Like, people aren't used to taking in online judge inputs. So when you deal with that, when you figure out how to get it done, then it should be pretty simple for you to learn. What else? You'll notice that every time you get a submission, you're gonna get something like this. These are great explanations. Wrong answer. It just did not, it did not output what I was expecting. Time limit exceeded. It ran under the CPU time limit. That thing we talked about earlier. Compile error. The language that you're using can't even translate the code without crashing. Then runtime error is probably the hardest to diagnose, which is the code crashes while it's running. All of those are what you need to worry about if you see those big red scary things. It at least tells you what went wrong. What else? Honestly, Thomas's solution is very well done. I don't think I can go into any more depth than what he's already said. If you guys have any questions, whatsoever, then we should be good, and that should conclude our first lecture for the year. Next time we will be dealing with data structures, and that lecture will be given by one of our executives. Yeah, they prepared well in advance, and it should be a good time. Hope to see you guys next week. It'll be a lot of fun. You guys have an entire week to figure out these questions. We'll keep it open until our next problem set during our next lecture. And have fun with this. This is a really rewarding world to get into, and I look forward to getting to know all of you. Once again, if you have any questions, just give us a DM. I don't know how to end the stream without it being awkward, so I guess I'll just say goodbye.